right, if you want to stick around, I am going to talk about an extension. So in Math 1, we are going to be translating shapes like triangles, rectangles, etc. However, in your future math classes, you're going to be translating functions. And this is important for us to know so that we can graph more easily. All right, so first of all, let's study a common function that you might see in Math 2 and beyond. Well, first of all, here are some x values that we can plug in, some negative ones, 0, some positive ones, so we can see the shape of this graph. And we have a rule here. The rule is take the x coordinate and square it. So negative 2 squared is 4, negative 1 squared is positive 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So let's go ahead and graph these points and see what the graph of x squared looks like. Okay, let's connect the points. All right, so this makes a little shape and it's kind of curvy, not a straight line. It's kind of like a U shape, and this particular function is called a parabola. And this is also called a parent function. Okay, so there's going to be changes to this equation and it's going to change the graph, but it's going to kind of look like this main graph. That's why this is called a parent function, just like you kind of look like your parents. All right, let's take a look at another example. So we have our parent function x squared and it looks like this. Now, if I change the equation a little bit, how is that going to change my graph? Well, let's say now we attach on x squared minus 5. So let's plug these values into our new equation and get the proper y value. Negative 2 squared is 4 minus 5 is negative 1. Negative 1 squared is 1 minus 5 is negative 4. 0 squared is 0 minus 5 is negative 5. 1 squared is 1 minus 5 is negative 4. 2 squared is 4 minus 5 is negative 1. So these were the original y values, and now these are the new y values. So let's take a look at what happens to the y values. Well, it seems like the y values are subtracting 5. So how will that change our graph? That's right, it's going to move it down 5. So let's go graph these points and confirm that. Negative 2, negative 1. That was this point. Now it's down here. Negative 1, negative 4. That's this point. It moved down here. This point moved down here, here, and here. So you can see that our graph has moved down 5, okay? Which can be shown right here in the equation. Okay, so let's see if we change the equation in a different way, how that will affect our graph. So let's say now the equation is no longer just x squared, but x squared plus 2. Well, let's get the new y values and we will compare. All right, so plug these values into the equation and you should get 6, 3, 2, 3, 6. Well, if you compare the old y coordinates to the new y coordinates, it looks like the rule for it is that the y values are just added by 2. So what results will that have in our graph? That's right, it seems like it will move it up 2. So let's go ahead and graph these new points, negative 2, 6, So this original point moved up 2 to be here, -1, 3. This original point moved up 2. And every point is going to move up 2. All right, let's take a look at this example. Y is equal to, in parentheses, x minus 3. All right, let's take a look at our next example, which is y is equal to the quantity of x minus 3 squared. So do you notice that we have parentheses around the x minus 3 this time? That kind of tells us that our x coordinates are going to need to change, not our y coordinates. So we kind of want to undo what's happening here with this minus 3. So what's the opposite of minusing 3? That's right, adding 3. So let's take all of our x coordinates, which are right here, and let's add 3 to them so that we can get our new x coordinates. So -2 plus 3 is 1. -1 plus 3 is 2, 3, 4, and 5. All right, so we have created new x coordinates, but we're going to plug those x coordinates into this function, see what y values we can produce, okay? So 1 minus 3 is -2. -2 squared is 4. 2 minus 3 is -1. Squared is 1. 3 minus 3 is 0. Squared is still 0. 4 minus 3 is 1. 1 squared is 1. 5 minus 3 is 2, and 2 squared is 4. So now let's take a look at our tables comparing the x values and the y values. Okay, so what do you notice about the y values? They're exactly the same, but the x values, seems like we added 3 to each of them. So then our rule would be like this: xy equal to transform to x plus 3 comma y. So how do you think this is going to impact our graph? That's right. This is actually going to move it right 3. Okay, it's kind of opposite of what we would think here because we did the opposite to combat this minus 3 to get our new x coordinates. Let's go ahead and graph them. Okay, so our first point is going to be at 1, 4. So notice this point moved to the right 3. Next point is 2, 1, 3, 0, 4. So you can see this graph actually moved to the right 3. And here's our last example. So we have y is equal to the quantity of x plus 4 squared. So again, we have those sets of parentheses, right? So how can we combat a plus 4? What's the opposite? That's right, where you need to subtract 4. So let's go ahead and take away 4 from all of these x values. So -2 minus 4 is -6. -1 minus 4 is -5. -4, -3, -2. Now, what we're going to do is we're going to plug in these x values into this equation and see the y values that we will produce. All right, -6 plus 4 is -2, which was this original x value. And -2 squared is 4. -5 plus 4 is -1, which is this original x value squared is 1. So we're going to actually end up with the same y values again. So our rule will be x comma y. Seem like for the x values we subtracted 4, and for the y values it stayed the same. So then this will result in moving the graph to the left 4. All right, I hope you enjoyed this extension. If you need any help, please let me know.